Algebra students, unfortunately you have the longest video this weekend, but I'm going to try to keep it short and sweet. You've been reviewing how to isolate the absolute value of something so that it equals a number. Well, now we are going to think about the absolute value of something being less than or equal to a number, or less than a number. And what happens if the absolute value is greater than or equal to a number, or greater than a number? Let's think about it with a simple case of just the x. So let's say we had the absolute value of x was less than 3. I'm just going to draw a number line and we're going to start putting in numbers that we think work. 3, does 3 work? No, it doesn't. The absolute value of 3 is not less than 3. Does 4 work? No. Does 5 work? No. But 2 works. 1 works. 0 works. -1 works. -2 works. And what about -3? -3 doesn't either. It works just like 3. And -4, well, that doesn't work either because the absolute value of -4 is bigger than 3. So now we start to see, look what happens. All of these values in between worked. All of these values in between worked. And that looks a lot like an and inequality. So if the absolute value of something is less than a number, you get this situation where what's inside there is less than the number and what's inside there is bigger than the opposite of that number, and they happen at the same time. So what a lot of books will write is they'll say, hey, what's inside that absolute value is between those two numbers. Rewind this video, watch it again. Why do all the values between -3 and 3 work? Right? If you just test them, they work. 3 doesn't, that's an open circle. -3 doesn't, that's an open circle. But all the numbers in between do. If this had been a less than or equal to, then we would have just filled in those dots and 3 would have worked, but we would have gotten the same solution. So how do we make this harder? I know that's what you want. Well, I give you something like this. 2 times the absolute value of 3x minus 1 plus 5 is less than or equal to 7. So now we just solve getting the absolute value by itself. So I get 2 times the absolute value of 3x minus 1 is less than or equal to 2. I get the absolute value of 3x minus 1 is less than or equal to 1, and then I get what's inside the absolute value bars is less than or equal to 1, and what's inside the absolute value bars is greater than or equal to -1. I add I add 1 to both sides. I get a 0 here is greater than or equal to 3x. I get 0 is less than or equal to 3x. I get 0 is less than or equal to x. Over here, I get 3x is less than or equal to 2, and so I get x is less than or equal to 2/3. It's an and situation, so I have 0 here, I have 1 here, 2/3 is here, closed circle, 0 is here, closed circle, and it's everything in between. As a interval notation, it would be anything between 0 and 2/3 with brackets because we include those values. Watch that whole video again. Alright, hopefully you've watched that entire video again. Now let's take an easy example where we have the absolute value of x is greater than or equal to 3. Well, now by the same logic, I can figure out that all the values that are bigger than 3 work. None of the values that are smaller than 3 work. Until we get smaller than -3, then those work. -3 doesn't work because that's kind of the boundary position. But now it's an or situation. So when I get the absolute value of something is bigger than a number, then I get these two inequalities that what's inside there is bigger than that number, or what's inside there is less than the opposite of that number. So we've got a less than is an or, and a greater than is an and. Oh, whoops, I missed that. I messed that up. Don't write that down. I have a less than is an and I have a greater than is an or. And I had a student a few years ago come up with land of gore. So less than is an and situation, greater than is an or situation. Land of gore. So let's take a really hard example, would be something like 3 times the absolute value of 1/2 x minus 5 plus 2 is greater than or equal to, let's say, 11. So I start this problem, I subtract 2 from both sides. I get 3 times the absolute value of 1/2 x minus 5 is greater than or equal to 9. Now I divide everything by 3. I get the absolute value of 1/2 x minus 5 is greater than or equal to 3. So notice just why we reviewed solving absolute value inequalities. You always have to get the absolute value by itself. Now we can take what's inside there and say whatever's inside there has to be bigger than or equal to 3. It's a greater than, so it's an or situation. Or what's inside there has to be less than or equal to the opposite of 3. I add 5 to both sides, I get 1/2 x is less than or equal to 2. I multiply by 2, I get x is less than or equal to 4. I add 5 to both sides here, I get 1/2 x is greater than or equal to 8. I multiply by 2, I get x is greater than or equal to 16. This is an or, so my inequality would look something like this. 4, 8, 16. Closed circle here pointing out. Closed circle here pointing out. Interval notation from negative infinity to 4, bracket, union, 16 with a bracket to positive infinity. Rewind to halfway and watch that video again. Thanks guys, have a great weekend. Watch it twice, trust me. Peace!